Bismillahirrahmanirrahim. Assalamu alaikum. In the last session, we learned about the magnets, magnetic materials, and magnetized materials, and some basic properties of a magnet. Today, we are going to learn about the magnetic effect of current. Magnets are not only the magnets which produce the magnetic field, sometimes the current produces the magnetic effect as well. So, today we are going to learn about this. Magnetic field due to a current in a straight wire. Whenever you are having a straight wire through which a current, usually a DC current, is passing, you can observe that there is a magnetic field formed around it. When an electric current is passed through a wire, as shown below, a weak magnetic field is produced around the wire, like this. Suppose this blue one is a wire in which the direction of current is downward. You will observe that there is a magnetic field which is not visible, but you can detect it with different sources. For example, iron filings or the magnetic compass. This field will be in this direction, which is shown in the circles. You can find the direction with the help of right hand rule as well. You can detect it with a compass like this. Suppose the wire is passed through a cardboard, and on the cardboard you can place the compass, and you can place different compasses or a compass at different position. So this direction can be detected. If the current through the wire increases, the strength of the magnetic field also increases. Means the strength of the magnetic field is dependent on the current. So if the current is stronger, the field is stronger. If the direction of the current flowing through the wire changes the direction, the magnetic field around the wire also changes. Just shown in the upper diagram. The first diagram shows the direction of the current is downward, and the direction of the field is opposite to the diagram number 2, in which the direction of the current is upward. So the direction of field is opposite to that one. So the direction of the magnetic field produced by a current is given by the right hand grip rule, as I am going to show you. Imagine gripping the wire with your right hand so that your thumb points in the direction of the conventional current. Your fingers then point in the same direction as the field lines. That is why it is known as the right hand grip rule, because you are gripping the current carrying conductor in your right hand. Don't worry, it will not be harmful for you because the wire will be covered with some insulation. Okay, so direction of the current is upward, so the right hand's thumb indicating the direction of the current. The curl of the finger is in the direction of the magnetic field lines. Magnetic field due to the current is solenoid. Solenoid is a spiral roll of the wire. The current produces a strong magnetic field in the wire. It flows through, is wound into a coil. The diagram below shows the magnetic field patterns produced by current carrying coil. A long coil is called a solenoid. This spiral roll of long coil is called a solenoid. When the current passes through it, each loop has the same field as a single wire. So as a combination of the field, a stronger field is generated as shown in the direction as shown in the diagram. This field will be stronger than a single wire because the multiple fields will be joined together. If the current through the solenoid increases, the strength of the magnetic field also increases. The same thing. Field is dependent on the current. If we increase the number of the turns, then one more thing, it is TURNS, not TERNS, sorry. It is my mistake. Turns in the solenoid, the strength of the magnetic field also increases. Means it is dependent on the number of the turns as well. If the direction of the current flowing through the solenoid changes, means if it is altered, the field around the solenoid, and the poles of the solenoid also changes, means switched. So to work out which way around the poles are, we can use another right hand grip rule as shown below. Imagine that the gripping the coil with your right hand as shown in the diagram means in the direction of the turn of the coil, your fingers are placed. So the thumb is indicating the north pole. So opposite is the south pole. Okay. So direction of the current is indicated by the fingers and thumb indicating the north pole. Methods of magnetization. It is NETIS. Another mistake. Magnetizing by electrical method. Now we will learn that how we can produce magnets. It is called the magnetization. There is a method which is known as electrical method. A steel bar is placed inside a solenoid coil, which is a direct current pass through. For a while, you will observe that the iron coil will becomes a strong magnetic field is produced. This is also known as the electromagnet. When viewed at one end of the bar, the current flows in clockwise direction. That end becomes a south pole. If current flows anti-clockwise direction, it becomes a north pole. It is another way of finding the north and the south pole of the solenoid as well. And we can easily find the poles by using right hand grip rule as we have discussed already. This is the way. What you have done, just you have placed a steel bar inside a solenoid and nothing else. So a stronger field will be generated as compared to a single solenoid only. When you place a iron rod inside the solenoid, you will observe many times a stronger magnetic field will be formed. This is an actual solenoid is here. These two knobs are there to provide the current. Magnetizing by stroking method. We can produce magnets by stroking as well. A piece of material may be stroked with a permanent magnet by stroking it continuously from one end to another, never going in the reverse direction. It is most important tip. If you are going in the reverse direction, it will never magnetize. It becomes magnetized. In the first, single touch method is there, in which a single magnet is used, in which you can observe that only the north pole is touched. In each cycle, only the north pole will be touched, and it will be moving from north to south. At the start of the stroking, there will be no pole will be there on the steel bar, but finally the poles will appear in this way as shown in the diagram number 1. Divided touch method. In this way, you can observe in the second diagram, two magnets will be used. One south pole will be touched, and on other half the north pole will be touched. Now the method of demagnetization, another NE is here. This is another spelling mistake. Methods of demagnetization means how can we remove the magnetic properties of a magnet. There are different ways. First, by using alternating current, a magnet can be demagnetized. Is placed inside the solenoid. The solenoid is connected to an AC supply. The magnet is withdrawn away through the solenoid in the southeast direction while the AC current is still flowing. As the process is repeated, the magnet will be demagnetized, means it will remove its magnetic properties. Like this. This is a solenoid in which you are passing an alternating current and the magnet is passed through the solenoid in east-west direction. Demagnetization by heating. You can demagnetize a magnet by heating as well. If we heat a magnet strongly by means of Bunsen flame, the magnet will lose its magnetization. In any way you can heat it, it will lose its magnetization. Demagnetization by hammering. If you want to remove the magnetic properties, in case of heating, hammering also cause a magnetic loss of its magnetism. If the magnet is hammered vigorously while lying in an east-west direction, its magnetism becomes weaker and weaker. Finally, it will be demagnetized. Properties of temporary magnet and permanent magnet. Another spelling mistake in permanent. Temporary magnets are the magnets which have their magnetic properties for a very short period, while the permanent magnets have their properties permanently. Application of the magnetic effect of a current. Magnetic relay. A magnetic relay is a switch operated by an electromagnet with a relay. A small switch with thin wires can be used to turn on the current in a much more powerful circuit. For example, one with large electrical motor in it. Different high voltage circuits are usually controlled with the help of the magnetic relays. For example, you are using a lift in which very low amount of current is used in the panel, so that one user should be safe, and it will be a relay switch and high current will be flowing, that will be controlled by this relay switch in the motor. One more example for the high tension lines in the K electric, which is operated by the relay switches which have very low DC currents. When the switch S in the input circuit is closed, a current flows through electromagnet and it will magnetize this pole, the iron armature towards it, which closes the contact C. As a result, current flows through the output circuit and motor turns on in this diagram. You can see the contact C. Electromagnet is here. Whenever the current will be flowing through the electromagnet, iron armature will be attracted towards the electromagnet and the contact C will be closed. So the motor will be started as the circuit will be closed for it. Circuit breakers. It is used in the every home. A circuit breaker is the automatic switch which cuts off the current in a circuit if this rises above the specific values. We have set values for each circuit breaker. If we are using a particular appliance, we should know that how much current will be required for it. We will limit the circuit breaker to that particular limit of the current. If the current will be increasing, there must be a short circuit, so the circuit will be break. Or it can be reset with the help of the reset button. You can now see it very clearly in this diagram that how it works, and it is written over here as well. Loudspeakers. In loudspeakers, this is also one use of the electromagnets. Most loudspeakers are of the moving coil type shown below. I'm going to show you soon. The cylindrical magnet produces a strong radial spoke line. Magnetic field at right angles to the wire in the coil. The coil is free to move backwards and forwards and is attached to a stiff paper or plastic cone. If a current is passed through the coil, the backward and forward force acts on it. This follows from Fleming's left hand rule. We will discuss it soon in the next chapter. Loudspeaker is connected to an amplifier which gives out alternating current. This flows backwards, forwards, backwards, and so on, causing a force on the coil, which is also backwards, forward, backwards. As a result, the cone vibrates and gives out sound waves as it is produced by the vibration. The nature of the sound produced depends on the frequency and the amplitude of the alternating current flowing through the coil. This is the diagram which is cut from one side to show you the complete circuit, that how it works. Tape recorder. A sound wave sent into a microphone is transformed into an electric current, means alternative current, amplified and allowed to pass through a wire coiled around a donut shaped piece of iron, which functions as the, as the recording head. The iron ring and the wire constitute an electromagnet, in which the lines of the magnetic field are contained completely inside the iron except at the point where a slot is cut in the ring. Here the magnetic field fringes out of the iron and magnetizes the small pieces of iron oxide embedded in the tape. As the tape moves past the slot, it becomes magnetized in a pattern that produces both the frequency and the intensity of the sound signals entering the microphone. This is shown with the help of diagram. You can see that recording head over here, and which this coil is working and through which the current is passing, and the recording tape is recording. Magnetic screening of a magnetic shielding. Magnetic screening is protecting delicate instrument from stray magnetic field by placing delicate instrument inside the soft iron box. Some of the delicate instruments are there which damages because of the magnetic field, so these are secure by this screening. Since the soft iron is a magnetic material, so stray magnetic field lines can go through the soft iron as shown below, but the field lines cannot reach into the delicate instrument. It will protect the layer of the soft iron around it, like this, because magnetic lines tends to pass through the magnetic substances, so they will be passing only through the core, which is a magnetic substance, and the delicate instrument or component will be saved from this magnetic field. Thank you very much. Soon we will see you inshallah again with another video.